Okay, so now we're going to try and do a couple of examples, okay? And first, we're going to look at different forms of the equation and come up with the pertinent information that we need. So in this, I want you to state a direction vector and at least 2 points. Now, you might come up with more than 2 points, and this is what makes this unit a little bit challenging, is since I'm asking you for a point on the line, there's an infinite amount of possible answers, right? So I'll show you how to get some that hopefully you'll get the same ones as I do, but if you really wanted, you could be really entertaining and try and find some obscure one, and then I'd have to, on your test, actually go through and see if that one's correct. So first off, let's see if you can figure out what form of the equation this is. So the first one is A is xy equals 1 comma negative 2 plus k bracket 0, 3. So what type of equation is that? So this time, instead of asking Matt the Magnificent, we're going to ask his sidekick,
Ken.
Thank you, Ken. What type of vector? What type of equation is this?
The general equation?
That's right. All right, that's right. So this is the general equation. So first things first, which one of these coordinates, the xy part or the 1, negative 2 part or the 0, 3 is the direction vector?
0.
That's right, the 0, 3. So, oh. And we know that that part is the direction vector because it's the part attached to with the k. Sometimes the textbook tries to mess you up and write this part first and then the 1, negative 2 afterwards. But all you need to know is the one that has the k is the direction vector. And then I need at least 1 point. There's an obvious 1 point. What's one obvious point? Yeah. 1, negative 2. So that's an obvious point there. But the interesting thing is to try and figure out a second point. Now, if we stop and think about it, the second or any other point can be found by just changing the scalar multiple that you multiply the direction vector with. The first one is actually when k is 0, right? Because if k is 0, then this whole thing disappears, and you're left with the just 1, negative 2. So the easiest point to find is just to choose an easy value for k. And to me, the easiest value for k is 1, right? So 1 times 0, 3 is still 0, 3. And now you actually do the addition. You do the 1 plus 0, so that's, so I'll call that 0.1. This is 0.2. So 1 plus 0 is just 1. And then negative 2 plus 3 is 1. And that's another point. And this would be if k equals 1. So another point could have been found if we let k be 2. So if k was 2 times 0, 3, then we would come out with 0, 6. And now you would do your addition. 1 plus 0, and we get 1 again. And then negative 2 plus 6 is 4. And that would be a third point. And you can see now how this would get nasty because you could just pick any value for k, and technically you'd be correct. But I wouldn't tell you to be a smartass and get like negative 72 and then let me try and figure out if you're right or not. So, okay, let's go to B. First off, what type of equation? This one looks different, doesn't it? It doesn't look like any of the ones that we had seen before. If we look back on our list, like I don't see anything that says OP, but it kind of looks like one of the equations. Which one does it kind of look like? That's right. It looks like the general equation. Right? Good. The only difference is instead of having xy, it has an OP here. The OP stands for the the vector from an origin to a point. And if you remember back when we were doing direction vectors, we were saying that any direction vector could be starting at the origin and going to wherever that point is. So instead of the xy, it gets replaced by an OP. It's just a notation in your textbook likes to use. I don't like to use it. I like to use the xy one, but OP means the same thing. So this is, in fact, the same as A. So right away, someone can come up and tell me a direction vector and a point really easily. So we're going to ask our exchange student from Greendale College, Annie. Annie, what is the direction vector?
-1, 4.
Excellent. And the really easy point is?
-3, 4.
Great. Thank you. I'm just going to write that down. So direction vector is -1, 4. And an easy point is -3, 4. Awesome. Thank you. To find a second point, then, all we need to do is now choose a value for our scalar multiple. You'll notice the scalar multiple is changed to an R, but that doesn't matter, right? It could be K, L, it's just some letter. So again, the easiest way to find a second point is to let R equal 1. That way, when you do the multiplication, it's really easy. And then the next point then would be -3 plus -1. So a second point would be -3 plus -1 is -4. And then 4 plus 4 is 8. Okay, so we're going to zoom through the next few. So we have different forms here. What's C called? Symmetric, that's right. There's a little bit of symmetry to it. It's got something on the top, something on the bottom, and they look the same on either side of the equal sign, so I think that's where the symmetry comes from. But there's one little gimmick with this one that you need to be aware of. It kind of looks like symmetry, right? It kind of looks like the symmetric part, except you'll notice that the second one doesn't really look like a vector, a fraction. It is a fraction. It's over 1. So that's great, except there's something else that's wrong here. So sure, this is over 1. But you'll notice, sorry? That's right. You see it's 3 minus y, and it really should have the y first. So we have a little gimmick that we do to deal with that. What I would really like it to do is look like this. Now, since it's subtraction, am I allowed to just change the order? No, right? I can't just take the y and now put it first. Remember, if you do like 5 minus 2 and you switch the order and 2 minus 5, that gives you a completely different answer, right? So there was a little gimmick we did last year and I think even first semester. What we do is we are going to multiply the top and bottom by -1. So if I multiply this top by -1, this becomes a minus, and this becomes a plus, right? And of course, whatever I do to the top, I have to do to the bottom. So this becomes -1. Notice because this is now -3 plus y, that the plus y can come out front, and the -3 can come second. And then all we have left then is over -1. So it's important that it's in this notation before you can actually read the information off it. The first part's okay though, right? The x is in the right spot, -4 over 2. Okay, so looking at this, the direction numbers, remember, come from the bottom. So do you think you can tell me what a direction vector is? That's right, yeah. We get the 2 here and the -1 there. 2 comma -1. That's our direction vector. So the negative has become really important. The fact that the original question had the y backwards influences that. Now the tricky part is coming up with the xy. And we'll have to remember where this x minus 4 comes from. If we look back a couple of slides, in this particular example, it was x minus 5. Where'd the x minus 5 come from? Well, it came from right here, 5, 4, and it was taken to the other side. That's why it became x minus 5. But what's the actual point? 5, that's right. So if we look at this, x minus 5, we know that the point is 5. And then even the same with the y, right? Y minus 5, the point is 4. And you can see it coming from that. It's a lot like when we had the numbers inside the brackets before, we did the opposite to what we think. When we saw x minus 5, we knew that that actually meant to the right 5. Exactly the same idea here. So when we go back to our example, we see it's x minus 4. So what's the x coordinate actually? Yeah, 4. X minus 4, opposite to what we think, is plus 4. And then the y minus 3, the other y coordinate is what? 3. And so our point is 4, 3. So now the question is, how do I get a second point? Well, we're going to do the exact same thing that we did if it was in the other notation, the general form. Take our point and add on scalar multiples of our direction vector. So all the information is right here. There's our point, and we're going to add on a scalar multiple of our direction vector. So we can almost pretend it's in the other form. What's the easiest scalar multiple to add on? When k equals 1. So just go off and take your 4. You're starting at 4, 3. You're going to add this scalar multiple. So you're adding the 2, or yeah, the scalar multiple of the direction vector. So a second point is 4 plus 2 is 6. And then start at 3 for your y. Add on the scalar multiple of your direction vector. Add on -1. So it's 3 plus -1 is, no, not -2, 2. And we get a second point. Again, we could add on double the direction vector, and that would get you a third point. Or we could add on a negative of the direction vector, it would get you a fourth point. Okay, D. D is in vector form. The direction vector is really easy to see. Again, it's the thing attached to the k part. So what's the direction vector in D? 3, -5. And our point comes from the stuff in brackets, and it's just like the top of the part of the symmetric equation. Make sure you read it sort of opposite to what you think. What's the x coordinate of our point? 1. Since it's x minus 1, we do the opposite, and it's 1. And then what's the y coordinate, do you think? 0, that's right. To find a second point, same thing. We start with this point, add on a scalar multiple of the direction vector. The easiest scalar multiple to add on is 1 times the direction vector. So we're going to start at 1, add on 3, and a second point then would be 4. Start at 0, add on -5 is like -5, and we get 4, -5. Last one, parametric form. Again, think back to what we had before. Any guesses of what the direction vector is? Sorry? -1, 3, that's right. If we look, remember the direction vector is the scalar multiples that are multiplied by that k or t or s or l or whatever, right? Doesn't matter what letter. So we got to find those within the parametric equation. Again, this question is trying to mess you up by changing the order in the second one, but no big deal. So for starters, there's our t. The coefficient is -1. So our direction vector must be -1. And then down here, don't get fooled by the order. There's our coefficient on t. So the direction vector is 3. A point comes from choosing a value for t, that's choosing a scalar multiple. The easiest one to choose is when t equals 0, right? And so if t equals 0, what's the x-coordinate? 4. If t equals 0, what's the y-coordinate? -1. You really don't have to think too much to actually do the math. You can see it right there. There's your 4 and -1. How do you find a new direction vector? Choose a scalar multiple, just like we've been doing this whole question. So we'll choose t as an easy scalar multiple. The easiest one, of course, is 1. So if we choose t equals 1, just imagine and put it in your head if that's a 1 and this is a 1. So the x-coordinate would be 4 minus 1. So that's 3. 3 times 1 is 3, so it's 3 minus 1 is 2. The reason I like parametric so much is that it's very easy to find points. You can clearly see the x-coordinate is given by just choosing a value for t, and then solving, and your y-coordinate is found the same way.